Okay, no problem. No problem. No, 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 no. Keep it like that. So let's do this example. Uh, so if you have something like this, there is no problem, right? The resistance is rho times L over A. But what if you have something like this, and the current is flowing in this direction?
Integral?
Yes, there will be an integral here. This is B, this is A. Let's find the resistance in that direction. So you can think of it as tiny conductors put together. And we basically have a distance, let's say distance x. And at a distance x, you have some r. And let's call this one dx. So what is the tiny bit of resistance because of that tiny bit of part? Rho dx over pi r squared. Everybody agrees with this? Yes?
Can you explain this?
Sure. So we are assuming that this one is not change. The radius is not changing for this dx. So we simply have a disk, okay? And the area of the disk is pi r squared, so area is that. And the length of the disk is dx. And the rho is rho. So I have dr, tiny bit of resistance because of this cylinder, this disk. And then I sum up the disks to get this weird shaped cylinder, cone. Yes?
For each dx, r is changing.
Yes, r is changing. Let's find it out. So you cannot just simply integrate dx, then you get rho L over A again. So we will find something else because r depends on x. So how would you find r? Let me tell you this way. If I write Rx is equal to, so I'm going to start with A, right? I start with A at x equals to 0. And when x becomes L, it becomes B, right? So I will add B minus A to it so that it becomes B at the end. And I will multiply it with x over L. So whenever x is L, over here, r is B, because B minus A plus A is B. Whenever x is 0, r is A. Did you follow this? And otherwise, the equation is linear, which represents this linear change. Everybody's with me here? Yes? So I have this integral that looks like this. dr is equal to rho times, let me just write rho over pi times dx over a plus b minus a x over L squared integral. Going from, where do we go? From 0 to L. Everybody agrees? Yes? So I can just define u to be a plus b minus a over L times x, and du will be b minus a dx over L, right? And the integral becomes du times L over b minus a, that's dx, right? Divided by u squared. Then r becomes rho L over B minus A integral du over u squared. I forgot pi. Yes, I will put the limits at the end. R is equal to, I'm going a bit faster because this is integral and it's a bit boring, right? So minus 1 over u. Did I make a mistake while trying to go fast? No, I didn't. So u is, actually u itself is changing between A and B, right? It's better to put u.
A to B.
Right? So I go from A to B. So as a result, I have rho L over pi minus A, sorry, rho L over pi B minus A times 1 over A minus 1 over B. R is equal to rho L over pi AB. Further? Yes, tell me.
I am a bit confused. We didn't integrate from 0 to L instead of A to B.
That's a very good point. So I did integrate from 0 to L when it was dx. Then I changed to du. Then at the end, I realized that
Sure, okay.
I just can use the u limits because they are simpler. Yes?
We called it U, but it is actually the radius.
Yes, exactly. Exactly. So as you can see, we arrived at a simple answer.
Very much.
Are you happy? Good. Yes.
A couple questions.
So let's continue with another example. Before that example, let me ask you something about capacitors. You might be confused whether this one is in series or in parallel and stuff like that. So let me ask you this. So I have a switch here that charges the capacitor C1 fully charged at first, okay? I'm solving this problem because I told you something about capacitors in series, capacitors in parallel, and stuff like that. You might have memorized them, and you might, this is a bit of a trick question. I was going to ask this in the quiz and said that, no, it's too tricky for a quiz. But you will see that it's not that tricky. So my message here is that just be careful, okay? Think about the physics of the system. Don't just memorize what I tell you. So it has been charged fully like this. And then the question asks us, when it switches to this position over here, what are the charges at the end of the day? Do you understand the question? So let's start with the first situation. How much charge will be deposited on the capacitor?
C1 times V.
C1 times V. Do you want this to be V? Is it okay if it's E?
Yes.
Yes. So at the beginning, there will be plus C1 times E here, minus C1 times E here. So far, so good. No tricks so far, right? But then, when you switch over here, the tricky bit is that when I told you about capacitors in series, I told you that there is a part of the circuit that is independent, so the Q's must be the same and things like that. Do you remember? So this is an exception to that, because before this became separated from the circuit, it has been charged. Do you see the point here? Yes? So once I switch over here, the charge needs to redistribute accordingly. Now, the principle that we use here is this. Remember, this is a very strong principle. If you have no circuit elements, then the potential must be the same over here and over here. No circuit elements in between. So eventually the potential must be the same over here. Okay? What does it mean? It means that the potential difference of this one must be equal to the potential difference of this one. But in the meantime, so eventually this will turn into the following situation, right? There will be plus Q2 here, plus Q1 here, minus Q1 here, minus Q2 here. This is C2 and this is C1. So although they are in series, okay, in terms of the formulas, they are in parallel. Because when they are in parallel, we say that the voltage is the same, right? Are you following? Okay. So the potentials are the same. That's why Q1 over C1 equals to Q2 over C2. Do you agree? And Q1 plus Q2 is?
EC1.
Yes. C1 times E, as we have found before. Do you agree with this? So that charge that was deposited here is redistributed to Q1 and Q2. As a result, I can find Q1 by writing 1 plus Q1 is C1 over C, no, Q2 is C2 over C1. I'm not sure about this. Q2 C2 over C1. Are we sure about this? Okay, let's see where it goes. Then Q1 is C1 squared E over C1 plus C2. Right? And what is Q2? It's C1 C2 over C1 plus C2 times E. Okay? Any questions related to this question? No? Did you get it? Did you get the subtlety here? Good. Now let's solve a problem that has capacitors and resistors, but it's a time-independent problem, so we will be able to solve it with the knowledge that we already have. But if it was a time-dependent problem, then we would need further knowledge of RC circuits. So this circuit has been like this for a very long time, let's say. Okay? Then, and we are given certain values, like R1 is 7 ohms, R2 is 4 ohms, Q is 35 microcoulomb, and C is 6 microfarad. The question is, what is E? E equals to what, and what is I? What is the current in this circuit, and what is the EMF? Okay? Let me ask you, what is the current that passes through capacitor?
0. That's already charged.
0 because it's already charged. Very good. So the capacitor has zero current flowing, which means that this I comes here and just turns over here and continues over here. So we have only one current that is running in one of the loops. All right? Then we can simply write, okay, let me give you another question. If I have point A here and point B here, as I said, it's a very powerful thing. So do you agree that this also has potential A at that point because there was nothing in between? And also this point has the same potential because there's nothing in between. Also this one has the same potential, nothing in between, right? This one has the same potential, nothing in between. So the potential difference on top of the capacitor must be the same as the potential difference over the resistance R1. So this tells us that I times R is equal to Q over C. In particular, I times R1, right? So I times 7 ohms is equal to Q 35 over 6. So I is 5 over 6 amperes. Okay? How can I find E? Yes?
E is equal to I times R2 plus R1.
R2 plus R1. So let me ask you, why it seems like E is here and capacitor is here, why the voltage difference over here is not simply the voltage difference over here?
I mean, you could also start naming other points and see that those potential differences are different. We need to draw
You see,
schematic better before we make conclusions.
yes, so you see the point B here can be transferred here. This also has the same potential, but the point C here has a different potential because when I go from this point A over here, I encounter one circuit element. Do you see? Good. But on the other hand, the potential difference between B and C, which is E, is basically the sum of the potential difference over here, right? So I can just write I times R2 plus R1, which is 5 over 6 times 7 plus 4. So E is 55 over 6 volts. All right? Any questions? You won't believe it, but we are actually done with this chapter. And we have 20 minutes to go. Should we start the next chapter? And the answer is yes. Because then you have even more time in the future. Attendance sheet is rotating. Okay. Wherever the attendance sheet is, please. Do you have any particular questions? Yes. EMF. Yes. Yeah. We said that the potential difference over here is not equal to this. Why? Because you see, these 2 points are here, right? If there was no R2 here, then that would be the case. R2 is starting problems, making problems. Yes.
May I ask something about previous question, please?
Yes. This one.
Yes, this one. In the a little bit bottom, you write something like 1 plus C2 divided by C1 times Q1.
Yes.
How can we find it? Like, I listened to it, but I didn't understand.
Sure. So I used this and I wrote Q2 is equal to Q1 times C2 over C1. Okay. Then I took this and put it here. Yes.
Can I also ask something before this question?
Before this question. Yes.
Can you scroll up? I didn't understand Rx here.
All right. Very good question. So when x is 0, so I want Rx equals to 0 to be A. Do you agree?
Yes.
I also want Rx equals to L to be B. So I start with A, okay, so that I make sure that I will get A if I have a linear coefficient here. So whenever this is 0, it will be A. And then I add the difference divided by L so that when x is L, this is 1, so I get B minus A plus A equals to B. So
But A needs to be 0, right?
what? A?
B is not 0. I mean, when x equals L, A is 0, right?
When x equals L, R is, we are not, A and B are positive values. They are constants. R is changing.
Okay.
Okay? Done? Yes. Any other questions from before? No? Let's move on to the next chapter. Let me close the alarm that would tell me that there is a quiz. So we have 12 more minutes. Let me just do something. Chapter 26. And this is direct current circuits. The beginning of this chapter you know very well. So I will actually write it as quickly as possible. So when you connect resistors in series, then what is the equivalent resistance?
R1 plus R2 plus R3 total 2.
Siri asked to who? What is equivalent resistance to who? Yes, exactly. You are right. So if I'm making an analogous circuit for this one, like this, you already know what it is, right? R equivalent is R1 plus R2 plus R3. Do I not need to linger on this for any longer? You know this, right? And when they are in parallel,
Use the reciprocals.
reciprocals are equal, right? But sometimes resistors are neither in parallel nor in series, okay? That's when you use Kirchhoff's rules. Okay? Let's use Kirchhoff's rules. Let's first define them. You are with me, right? Yes? Kirchhoff's first rule tells you that what goes in comes out. Very easy to remember. Let's say you have a node and there are ingoing circuits and outgoing circuits, right? I1 going in, I2 going in, I3 going in, I4 coming out, I5 coming out. So it says that thank you very much, sum of the currents going in is equal to sum of the currents going out. Okay? Any questions here? No? So it's because of the conservation of charge. The second rule tells you that potential difference over a loop is 0. It has an exception, by the way. Over a loop is 0. The exception happens later on in the chapters, later on. When you are applying magnetic field on the circuit and you are actually changing the magnetic field, you are creating a non-conserving electric field. So you can actually no longer talk about potential there. Okay, it's tricky. But whenever you don't have magnetic field changing around it, this is true. Okay? So let me give you an example. Let me just sketch you how I think about this. So I'm giving you this circuit. 1 ohm here. 9 volts over here. 1 ohm, 2 ohms. Here is how I apply the second rule of Kirchhoff's, the second Kirchhoff's law. I usually start with a home, which is right at the bottom of the battery. That's my personal choice. You can start wherever you want. Okay? And then I start walking in a certain direction. I usually walk towards plus of the battery. So what do I encounter first? I encounter an increase in voltage, plus 9 volts. Yes? Okay. Then, as you can see, we encounter a current here that is moving away from us. When the current moves away from us, it means that where we are going is lower than where we are. That's why it's flowing that way. Do you understand? So the potential is decreasing. Then I take minus I times R, which is minus I times 1. Okay, keep moving, and I encounter another river flowing away from me. So the potential decreases one more time, right? So I have minus I times 2 equals 0. Y equals 0 came back home. Do you see? It's that simple. Start from home, potential increases, decreases, back home, the total is 0. So this tells you that 9 is 3I, so the current is 3 amperes. Of course, here you didn't even need Kirchhoff's rules to solve this, but you will need it at other situations, right? Let me give you that particular situation. So in this particular case, the resistances are neither parallel nor in series, okay? So you can't solve it using the good old theory. you need to use Kirchhoff's rules. So this one is 1 ohm, this one is 3 ohms. There is current 2 ampere coming from here, 1 ampere coming from here. This is 12 volts. Okay. This is not known. This is not known. And this is not known. Do you understand the question, everyone? Yes? So, let's look at this system. It has 2 loops, right?
3 loops.
Okay, very good point. It has 1 loop here, 1 loop here, and maybe you can say another loop here, but that 3rd loop will not give you something that is linearly independent of what you have found already. Did you follow this? Yes or no? So this loop will be just summation of the equations that you find from this 2 loops, so it will not give you new information. 2 loops are enough to solve this. So let's start with this loop. So I put my home here, right? And I start moving in the positive direction. What do I get? Plus E. Then what do I see over here?
6.
Plus 6.
Yes.
Why
We
plus?
are in the moving of the opposing current.
Yes. So we see a flow that comes towards us. So we are moving in this direction. And we see a river flowing towards us, which means that wherever we are going is higher than where we are. Do you see? So plus I times R, plus 2 times 3. Then we see another river going away from us, right? So minus 1 times 1. Okay? Apparently this was a trick question. The battery, it turns out that E is negative 5
You will just
volts.
flip the battery.
So we plotted it like this, but turns out that the battery was looking like this. Do you see? Yes? All right. So let me just rearrange this so that you are not confused at home. So this will start with a minus, and the rest is correct. Sorry about this. I think I cooked up this problem before, and I had the same mistake here, right? But I kept it. Anyways, so how can I find I? Can you tell me?
There is 2 and 1 is going in.
Yeah, exactly. So first law of Kirchhoff's first rule. So 1 plus 2 must be equal to I. So the current is 3 amperes. And finally, we can do it now for the last one. So let me put a new home here. Okay. And let's start moving in this direction. So I have plus 12 volts. What do I have next? Minus or plus? Minus I times R, very good. Then what do I have next? Over here? Minus 1 volts, 1 times 1. Right? And finally, I have minus E, minus 5. Let me just write minus 5. Equals 0. So what do I get? 6 equals to IR. Then R is equal to 6 over 3. which is 2 ohms. Okay? So we have applied Kirchhoff's rules to this circuit, and we couldn't have solved it any other way. Yes.
Why 5 is minus?
5 is minus because we have changed the direction of the battery later on in the problem. Sorry about that. But when you go from plus to minus side of the battery, that's when you get minus 5.
You charge up to that.
Yes. Any other questions? So, those who want office hour, I will be in my office next 1 hour.